In this video, we discuss learning outcome number 5 from lesson 5.1. Here we identify a result as a significantly high number of successes or a significantly low number of successes using probabilities. Before we do that, we need to talk about what a trial of a procedure is and what we mean by success. Now, a trial is just a particular run of a procedure. So maybe the procedure is flipping a coin. So if you flip the coin once, that would be one trial. If you flip the coin 100 times, that would be 100 trials. Similarly, one trial might be a single birth of a single child. If we look at 20 births, that would be 20 trials. Now, when we define success in one trial, we're just talking about a particular outcome of a procedure. And we're going to think of that procedure as having two outcomes. So we either have success or we have something that we're not classifying as success. If you want, you could call it failure. But what we define to be success is pretty arbitrary in this context. So for example, if we're flipping a coin and we're calling that one trial, and we flip the coin 100 times, that's 100 trials. We might define success to be flipping heads. So if you got 47 heads out of 100 flips of a coin, we would call that 47 successes in 100 trials. Now, we could have just as easily defined success to be flipping tails. That would be fine too. If we flipped heads 47 times, then we would flip tails 53 times. And that means that if we flip tails 53 times out of 100 flips of a coin, we'd have 53 successes in 100 trials if we decided that flipping tails was what we defined to be success. It really doesn't matter which one you call success, you just have to be consistent. Once you've made that choice, all of your other calculations need to be consistent with that choice. And all of your interpretations of results need to be consistent with that choice. Similarly, we might be interested in probabilities among 20 births. So we might say a single birth is a trial and 20 births is 20 trials. You could define success to be a male baby. So if you had 8 male babies in 20 births, you could call that 8 successes out of 20 trials. Or you could define success to be a female baby. So maybe there are 12 female babies born out of those 20 births. Then you would have 12 successes out of 20 trials. It really doesn't matter if you call having a male baby a success or a female baby a success. Once you define it, as long as you're consistent with it, you can use that in your calculations and then use that, of course, in your interpretation of what you calculate. And now we're ready to talk about significantly high numbers of successes and significantly low numbers of successes. So we're going to say that X successes among N trials is a significantly high number of successes if the probability of getting X successes or more successes is less than or equal to 0.05. Notice that when we're talking about a significantly high number of successes, we're looking at the probability of X or more. Significantly high goes with X or more. Now, I know probabilities in this class are always numbers between 0 and 1. We use proportions, and sometimes we list those proportions as fractions rather than these simplified decimals, but it's often convenient and helpful to convert probabilities to percentages to help with understanding. So that's what I've done here. What this highlighted statement says is that the probability of getting the value X, so X successes, or more than X successes is less than 5%. So that's saying that that event of getting X successes or more successes is pretty rare. We define X successes among N trials to be significantly low. It's a significantly low number of successes if the probability of getting X successes or fewer successes is less than 0.05. Again, that's saying that the probability of getting the value X, that's X numbers of successes, or fewer numbers of successes is less than or equal to 5%. Now this 5% or 0.05 probability is not absolutely rigid. Sometimes we might be interested in that these probabilities being less than or equal to 0.01. So that would be a probability of getting X or more, or X or less, or X or fewer. That's less than 1% instead of 5%. Now, if that probability is less than 5%, that's what we're saying here, then these events are rare. They're pretty rare. That's what we are defining to be significantly high or significantly low. Now, remember this rare event rule from inferential statistics. That's relevant here because we're talking about rare events. Remember, the rare event rule says that if, under a given assumption, the probability of a particular observed event is very small, and the observed event occurs significantly less or significantly more often than what we would typically expect given that assumption, we can conclude that the assumption is probably not correct. Now that's a lot. Let's try to unpack that. So it says if under a given assumption. So you're assuming something is true. Based on that assumption, if the probability of a particular observed event is very small. So you've got some event under and this assumption, we say that's pretty unlikely. That's not likely to happen. But then the observed event occurs significantly less often or significantly more often than we would expect given that assumption. So the probability was small, and then we say, but wait a minute, it's happening all the time, then maybe that assumption is incorrect. That's the rare event rule. And this is relevant because statisticians tend to reject explanations based on very low probabilities. This is going to be very important later this semester when we talk about hypothesis testing in chapters 8, 9, and 10. Now, before we do an example, I wanted to compare the range rule of thumb method for defining significant events and the probability method that we just talked about. We just said that significantly low values of a variable are given by the mean minus 2 times the standard deviation, or a value that's lower than that. And we said that significantly high values are given by the mean plus 2 times the standard deviation, or higher than that. Now, when we're using probabilities and we're talking about X successes among N trials, we say that there is a significantly high number of successes if the probability of getting X or more than X is less than or equal to 0.05 or 5%. And we're going to say that getting X successes in N trials is a significantly low number of successes if the probability of getting X or fewer successes is less than or equal to this 0.05 or 5%. I want you to see this graphic so that you can wrap your mind around this idea. In either case, we're talking about these values in the tails. These values that are close to the mean are not particularly significant. But with the range rule of thumb, what we're saying is if a value is more than 2 standard deviations away from the mean, so it's maybe more than 2 standard deviations above the mean, that would make it significantly high, or more than 2 standard deviations below the mean, that would put us over here on the left, that would make it significantly low. That's what we're going to call significant when we use the range rule of thumb. Now, when we're using probabilities, we're not using a number of standard deviations to define that cutoff anymore. Now we're looking at the probability that we have X successes or more than X successes. So maybe if we're talking about like 100 trials of something, maybe you're looking at the probability of getting 98 successes or more than 98 successes. So 98 successes or 99 successes or 100 successes. If that probability is less than or equal to 5%, we're going to say that that's pretty rare. That's like in the top 5% on the high end. So that's significantly high. Now, if we have a value on the low end, so you are looking at a particular number of successes and you're saying is that value significantly low, then you're saying, well, what is the probability of getting that value or some value that's less than that? If get the probability of getting that value, that number of successes or fewer successes is less than or equal to this 0.05 or 5%, then we're going to say that that's significantly low. So this is in the bottom 5%. Over here, we're talking about being in the top 5%. So that's what's going on. They're very similar. We're interested in what happens in the tails. Things that happen close to the mean are not particularly significant for us, but we're going to say that something is rare using the range rule of thumb if it's more than 2 standard deviations away from the mean. So it would be significantly high if it's more than 2 standard deviations from the mean on the high end, and significantly low if it's more than 2 standard deviations from the mean on the low end. Now, when you're talking about using probabilities, the cutoff is 5% either way, and you want that probability to be less than or equal to that 5%, or in decimal form, 0.05. But notice what we have in parentheses. When we're talking about X successes, when we're talking about a significantly high number of successes, we want the probability of having X successes or more than X successes to be less than or equal to that 0.05 or 5%. Or on the low end, when we're talking about an X number of successes, we want the probability of getting X successes or less than X successes or fewer than X successes to be less than 5% in order for us to call that a significantly low number of successes or a significantly high number of successes. So we're using probabilities as our cutoffs here, and in the range rule of thumb, we're using this number of standard deviations from the mean. But either way, we're looking at what happens in the tails, and if something is very high or very low with different cutoff, like different ways of cutting off what's significantly high and significantly low between the two methods, then we're going to say that those values are significant. Okay, so let's look at an example. It says 5 males with an X-linked genetic disorder have 1 child each. The random variable is the number of children among the 5 who inherit the disorder. So if you have 5 males, each with 1 child, and you're looking at the number among those 5 children that inherit the disorder, you might have 0 children in the 5 that inherit the disorder. You might have all 5 of them that inherit the disorder, or you might have some value in between. And then we've got this probability distribution to the right, which we've looked at before in other videos. The problem statement says, use the probability distribution to determine whether the outcome of 1 child in 5 is significantly low. So this time we're determining whether a value 1 in 5, this is X equals 1, is significantly low. This time we're not using the range rule of thumb like we did in the last video. This time we're using probabilities. Since it's talking about X equals 1 being significantly low, we need to find the probability that X is less than or equal to 1 using this table. So the probability that X is less than or equal to 1 is the probability that X equals 1 or the probability that X is less than 1. So X could be 0. And that's what we mean when we say significantly low. We're saying, what's the probability of having 1 in 5 of those children that have a genetic disorder? And then what's the probability of having an X value that's more extreme than that? And when we say more extreme, we mean lower than that in this case, smaller than that in this case. So we're looking at having 1 child with a genetic disorder or 0 children with a genetic disorder. And we want the probability that X is less than or equal to 1. Well, the probability that X is less than or equal to 1 is the probability that you have 1 child with the disorder, or plus the probability that you have 0 children with the disorder. I was about to say or, and I could have used or, because that's absolutely correct here. The probability that X is less than or equal to 1 is equal to the probability that you have 1 child with the disorder or 0 children with the disorder. And then according to the addition rule, we just add those two probabilities together to get the probability that X is equal to 1 or X is equal to 0. So the probability that X is equal to 1 is listed here in the table. You just write that down. The probability that X is equal to 0 is this. You write that down and then you add them together and you get that. So the probability that X is less than or equal to 1 is 0.187. Now we want to take that probability and compare it to 0.05. It's clearly greater than 0.05. So that means that X equals 1 is not significantly low. That's the same result that we got with the rare event rule, but with the rare event rule, we were looking at numbers of standard deviations from the mean. Here we're looking at probabilities. Let's think about these results and interpret what they mean. When we say that the probability that X is less than or equal to 1 is equal to 0.187, what we're saying is there's an 18.7% chance that there will be 1 child out of 5 or 0 children out of 5 that inherit the genetic disorder. 18%. Now 18.7% is greater than 5%. That's not particularly rare, and we're going to say that an event is rare if it's less than or equal, if it has a probability that's less than or equal to 5%. So this probability is definitely greater than 5%. So the event of getting 1 child in 5 is not considered to be significantly low using this method. So that's it for that learning outcome. I'll see you in the next video.